Hello, everyone. Today I'm going to show you how to use this interactive YouTube manometer solver. You can explore it through the link below. I'll also put it in the video description below so you can follow along. This tool helps you calculate pressure differences, height differences, and fluid densities using the manometer equation. It's perfect for engineering students, professionals, and anyone working with fluid mechanics. Let's dive in. A YouTube manometer is a simple device used to measure pressure differences between 2 points. As you can see here, it consists of a U-shaped tube filled with a measuring fluid like mercury, water, or oil. When there's a pressure difference between the two sides, the fluid levels change, creating a height difference that we call delta H. This height difference tells us exactly how much the pressures differ. The manometer equation is shown here. P1 minus P2 equals ρ times G times delta H. Let me break this down. P1 minus P2 is our pressure difference, ρ is the density of the manometer fluid, G is gravitational acceleration, usually 9.81 meters per second squared, and delta H is the height difference between the two fluid columns. The beauty of this solver is that if you know any three of these variables, it can calculate the fourth one for you. Let's work through an example. Say we have a mercury manometer with a height difference of 0.5 meter, and we want to find the pressure difference. First, I'll select Pressure Difference from the drop-down menu. Notice how the pressure field becomes grayed out. That's because it's now our answer field. Next, I'll select Mercury from the Fluid presets, which automatically fills in 13,600 kilograms per cubic meter. Then I'll enter 0.5 meters for the height difference. Gravity is already set to the standard 9.81. Now I just click Calculate, and there we go. The pressure difference is 66,708 pascals, or about 66.7 kilopascals. Notice how the visual diagram has updated to show the fluid levels matching our calculation. Let's try another example. I'll click Reset to clear everything. This time, let's say we measured a pressure difference of 10,000 pascals using a water manometer, and we want to know what height difference that represents. I'll select Height Difference from the drop-down. Now the height field is grayed out as our answer field. I'll enter 10,000 pascals for the pressure, and select water as the fluid with a density of 1,000 kilograms per cubic meter. Click Calculate, and we get 1.019 meters, or about 102 centimeters. That makes sense. Water is much less dense than mercury, so we need a taller column to measure the same pressure. This solver has several helpful features. First, you can choose from multiple unit systems, pascals, kilopascals, bar, or psi for pressure, meters, centimeters, millimeters, inches, or feet for height. There are also convenient presets for common fluids like mercury, water, and oil, or you can enter a custom density. The animated visual helps you understand what's happening physically, and if you scroll down, there's a complete formula reference and a detailed user guide section that explains everything. Here are some quick tips for getting the best results. Always double-check your unit selections. It's easy to accidentally leave a setting in the wrong unit. Choose the appropriate fluid for your pressure range. Mercury works well for high pressures with small heights, while water is better for lower pressures with larger heights. The solver displays all final results in SI units, which is helpful for standardization. And remember, you can always click Reset to start a fresh calculation. And that's it. You now know how to use the YouTube manometer solver for all your pressure calculation needs. The link is in the description below if you want to try it yourself. Whether you're a student learning fluid mechanics or a professional engineer, this tool makes manometer calculations quick and accurate. Thanks for watching and happy calculating.